Welcome to Trajectory Part 1. And before we start on the physics, we're going to take a quick look at the math we're going to be using. Stuff you've all seen before in your math classes. And it involves the definition of sine and cosine. So as always, we're starting with a right triangle, defining an angle theta. We have the hypotenuse here, the adjacent side here, and the opposite side here. Now, as you remember, the definition of sine function is nothing more than sine of theta is equal to the opposite divided by the hypotenuse. And the definition of cosine of angle theta is equal to the adjacent divided by the hypotenuse. Nothing you haven't seen probably 100 times before. Now, because we are dealing with velocities, we're going to rewrite these sides, or relabel these sides in terms of velocities. So we go back to our right triangle in our reference angle theta, and instead of a hypotenuse we have the velocity vector v. On the adjacent side we have the velocity vector v sub x, and on the opposite side we have v sub y. Redefining or rewriting our sine and cosine functions in terms of these labels, we get simple definitions. Sine of theta is v sub y over v. Cosine of theta equals v sub x over v. And rewriting these two equations in terms of v, first of all, v sub y gives us v sine theta, and v sub x gives us v cosine theta. And something to keep in mind, the process of finding v sub x and v sub y is called resolution of vector v. So if you ever hear the expression resolve this vector, all it means is find the x and y components. And because in this case we're dealing with velocities, it's v sub x and v sub y. I'm going to give you 3 examples. 3 seems like overkill. I'm giving you 3 in case 1 just doesn't do it for you. If you feel you're in command after 1, skip to the end, do the practice problems, and compare your answers to the solution set given. I'm going to start with our first example here. Is going to be an example of a soccer ball kicked at 20 meters per second at an angle of 25 degrees. In fact, it's 20.0 meters per second. V sub x is here. V sub y is here. I'm going to find the value of v sub y. Very simple. We'll use the 2 equations we just finished. Sine theta, v sub y equals 20 meters per second times the sine of 25 degrees. V sub y equals 20.0 meters per second times 0.42, and v sub y is 8.5 meters per second. V sub x, found a similar way, just using the cosine function, cosine theta, v sub x 20.0 meters per second, cosine 25 degrees, v sub x equals 20.0 meters per second, 0.91, the value of cosine of 25 degrees, v sub x is equal to 18.1 meters per second. Does this make sense physically? Yes. We notice that 25 degrees is a fairly shallow angle, so we expect most of the velocity to be in the x direction and only a little bit in the y direction. We have that. We have 18.5 in the y or vertical direction and 18.1 in the x direction. Example number 2 is not the opposite, but we're going to take a look at what happens when the angle gets steeper. And here we have an example where we have an object with a 10 meter per second velocity, at an angle of 70 degrees. We're going to take a look at v sub x, v sub y. Pretty simple. Over and over again. This helps us remember what we're learning. 10 meters per second times the sine of 70 degrees. V sub y, 10 meters per second times 0.94, which is a sine of 70. V sub y is just straight away 4.9 meters per second. Horizontal velocity v sub x, v cosine theta, v sub x is equal to 10.0 meters per second, cosine 70 degrees, v sub x. And then v sub x turns out to be 3.4 meters per second. Again, take a look at the physical reality. Do we expect a lot of motion vertically or horizontally? Vertically, because of such a steep angle, and you notice that that is correct. V sub y is greater than v sub x over 2 times. Last but not least, the third example, someplace in the middle, and we have an object moving initially at an angle of 40 degrees and a velocity of 75.0 meters per second. And just finding v sub y and v sub x, probably becoming second nature and a little bit boring for you by now. You're probably asking yourself, why bother writing all this stuff out? I can just plop it in my calculator and get an answer. Well, if you're just learning this or you're doing this for review, it's always best to write all this stuff out because it helps you retain what you've learned. And on a purely practical point of view, if you get to a test or a quiz, your instructor may give you extra credit for getting the procedure right, even though you might have made a math error, and calculators do not make you invincible when it comes to math. There's always a possibility of a keying error or something else happening. Okay, again, take a look at the situation here. We have 40 degrees, and you would expect the x and y components to be almost equal because it's almost splits the, makes it 2 equal legs in a triangle. And they're pretty close, 48 and 57. Not exactly on top of each other, but if we went to 45, you'd see they're the same. Following are 5 practice problems, and then following that are the solutions. No one likes to do homework, but a couple practices wouldn't hurt. Help you retain what you learned. Good luck.